Hello. Now, today I will be solving some questions from NCERT exemplar, okay, which are with concept-based questions. So the first question that I have taken, show that square of any odd integer is of the form 4q plus 1 for some integer q. So how will you do this one? Odd integer. So let the odd integer can be taken in this odd integer be an even number plus 1. This is the general form of an odd integer, that is even plus 1 is an odd integer. So I have to show square of the integer is of that form. So it is simple. So the odd integer say be a. So the square of the integer will be a square twice m plus 1 whole square. It's simple one, a plus b whole square, 4m square plus 2ab, 2 into 2m into 1 plus b square. So obviously from these two terms I can take 4 common, 4 m square plus 1 m. Here m square, here m plus 1. So m is an integer. So m square plus m is another integer. So it is of the form 4q plus 1, where q is an integer, m square plus m. So it is very simple. Now let us come to the next question. If n is an odd integer, show that n square minus 1 is divisible by 8. So n is an odd integer. Since n is odd, so we can write n as even plus 1. This is n. Now I have to show this divisible by 8. Divisible by 8. So now n square minus 1 can be written as a square minus b square is equal to a plus b into a minus b. So in place of n I can write twice n plus 1 into twice m plus 1, n is twice m plus 1 minus 1. So it is twice m plus 2 and it is twice m. So if I take 2 common here, it is m plus 1 into 2m, or 2 into 2 is 4, 2 into 2 is 4, then m into m plus 1. Now m into m plus 1 is product of two consecutive integer, and you know in any two consecutive positive integer, if one is odd, the other will be even, or if m is odd, then m plus 1 will be even, or if m is even, m plus 1 will be odd. That means among the two, one will be surely an even number, an even integer. So therefore I can write 4 into twice, say p. Why? Since m into m plus 1 is even. Product of two consecutive integer is always even, because one is odd, other will be even. If first one is odd, first one is even, the second will be even. So one of the number will be even always. So so it will be m into m plus 1 is an even. That's why I've written 2 into some integer p, where p is some integer. So therefore 8 into p, therefore n square minus 1 is divisible by 8. Hence proved. Hence proved. So this is the logic. Now main thing, this one you have to take care, that is product of two consecutive integer is always even. Or let me write it down here. Product of two consecutive integer is always even. It is obvious from observation. So, okay. Next question. Prove that if x and y are both odd positive integers, then x square plus y square is even but not divisible by 4. So here, since they are odd positive integers, so let write x is equal to some even number plus 1 and y is equal to twice n plus 1. We take the numbers in this form, the general form of odd positive integers. Then x square plus y square will be twice m plus 1 whole square plus twice n plus 1 whole square. Okay. So by the identity a plus b whole square, a square is 2m whole square means 4m square plus twice ab plus b square. Similar way, let me expand this one also. A is 2n, so a square is 4n square plus 2ab plus b square. So you see, in this, or let me write down one more step, 4m square plus 4m, and then let me take these two, plus 4n square plus 4n plus this one and this one, that is 2. So from these 4 terms I can take 4 common. M square, just a minute, m square plus m plus n square plus n plus 2. So it is 4 into, this is some integer, say p plus 2, where p is some integer equal to m square plus m plus n square plus n. So x square plus y square is of the form 4p plus 2. So obviously this number is not divisible by 4 because 2 is a remainder. So this is not divisible by 4. Is not divisible by 4. But this can be written in this way, take 2 common, 2p plus 1. So it is of the form 2, say q, where q is 2p plus 1. So therefore it is, what we have to prove, it is even. So it is even. So you have proved that when x and y are two odd integers, x square plus y square is even but not divisible by 4. Hence proved. Okay, now next 2 questions. The fourth one, prove that one of any 3 consecutive positive integers must be divisible by 3. Okay, so let us do this one first. So let, for question number 4, for any 3 consecutive positive integer, one will be divisible by 3. So let a be any positive integer, a be any positive integer, and let b is equal to 3. Then by Euclid's division lemma, then by Euclid's division lemma, we can write, if you remember, that was A is equal to, lemma was A was is equal to B cube plus R, where R is less than B and more than equal to 0. This was the Euclid's division lemma. So here B is 3, so I write 3Q plus R, where R is more than equal to 0 and less than 3. B is 3. Okay. So B, that means what? R can take the values 0, 1 and 2. These three values are allowed for R according to the lemma. So therefore A can be either 3Q plus 0 or 3Q plus 1 or 3Q plus 2. That means the three possible numbers are 3Q or 3Q plus 1 or 3Q plus 2. Now these are, if this 3Q, if I take to be a number, say n, 3Q is equal to say n, some integer, 3Q is some integer, so it will be n into n plus 1 and n plus 2. So you see n, n plus 1 and n plus 2 are three consecutive positive integers, and among these three only one is divisible by 3, that is 3Q. So therefore we can write, therefore yes, therefore only 3Q is divisible by, only 3Q is divisible by 3. So for any positive integer A, these three consecutive numbers can be expressions, out of which only one will be multiple of 3. Hence proved. Okay. Now next question. For any positive integer n, we have to prove that n cube minus n is divisible by 6. Okay. So what will you be doing? Now question number 5, I'll be solving now. N is any positive integer. So what is n cube minus n? N cube minus n can be factorized n into n square minus 1. If I take n common, then this can be further simplified or factorized, a plus b into a minus b. So this being factorized into 3 factors, or I can rearrange them. This is the smallest one, n minus 1, or I can write n cube minus n is equal to, write the smallest factor first, then into n plus 1. Again you see, this is expressed as the product of 3 consecutive numbers. N minus 1, n and n plus 1 are 3 consecutive integers, we find. So by this result of question number 4, that is, one of any 3 consecutive positive integer must be divisible by 3. So we can write, since these are the 3 consecutive positive integers, one of them will be divisible by 3. So you write, since n minus 1, n and n plus 1 are 3 consecutive positive integers, 3 consecutive positive integers, therefore one of them must be divisible by 3. One of them must be divisible by 3. And also, if you observe, product of any 2 consecutive number is always even. I have shown you in the previous question. Also, since product of any two consecutive positive integers is always even, we have shown, because out of two consecutive integer, if one is odd, the other will be even. That's why that product will be always even. So what we can write, say, because all are consecutive, so out of these three, one is divisible by 3 and product of any two is even. So what we can write, therefore n cube minus n, which is equal to your n minus 1 into n plus 1, I can write any one of them will be multiple of 3. So I can write it as 3 into, say, m into, and the product, suppose this is your 3m, then the product of the other two consecutive will be even. So it is 2n into 2n. Okay? Or no, don't let, because n is already there. Let me take some different integer. It will be confusing. So let me take 2 into, say, p, another some integer. So it is 6mp. M into p, product of two integers, again another integer, so I can write it as 6q, where q is equal to mp, some integer. So we have proved that n cube minus n is 6q, hence n cube minus n is divisible by 6, hence proved. So we have proved n cube minus n is 6 times some integer. That means n cube minus n is divisible by 6. So these are the logical explanation. Okay, that's for here I finished the real number chapter. So my next video will be on polynomials. Okay, thank you.